Hello, geometry students. It's day 7, and we are talking about angles of elevation and angles of depression. So all that means, that's a fancy way when we say we're elevating something, we're lifting it up, or in this case, you're actually looking up. So you can read through the first little paragraph, and it explains that when you have your horizontal line of sight, so imagine you're looking straight ahead, and then you look up at something, maybe the top of a house, a bird, whatever. The angle between those two lines of sight, that's your angle of elevation. So just think of elevation as you're looking up, right? And then the other term is called angle of depression. Now, I know we think depression is being kind of sad, but think of it as being, down. You're literally looking down in this case. So if you look straight ahead and then we look down at something, it's the angle formed in between those two lines of sight. And so when it says at the bottom, draw an angle of elevation and an angle of depression, how are the two angles related? I actually want to draw them sort of together. And so what I mean by that, if I think about, here's my cute little stick figure, their horizontal line of sight. So if they look straight ahead, and then if they look up at something, this is my angle of elevation. And so let's pretend they're looking at their friend who is, I don't know, in a building up here. So they're not floating in midair. Maybe they're like, I don't know, standing on a rooftop deck. We're not going to overthink this. Okay. If that person looks straight out and then looks down at their friend, the angle of elevation or depression, would be right here. And so both of their horizontal lines of sight are the same slant, so they're parallel. And so if I have these parallel lines here and I see that Z shape, these are actually alternate interior angles. Oops, making up my own spelling here. Alternate interior angles. And we should know if we have parallel lines, that makes alternate interior angles congruent. So your angle of elevation and depression should be congruent to one another. You just want to make sure that we're drawing them correctly. And that's what we're going to be doing on the next pages, is doing some drawing. So flip it on over here. Very first example. You obviously don't need to be a great drawer. I clearly am not. So do the best you can with these. It says at a point on the ground, 40 meters from the foot of a tree, the angle of elevation to the top of the tree is 42 degrees. Find the height of the tree to the nearest meter. Okay, as you're reading these, highlight or underline all the important stuff, or maybe even circle it. So a point on the ground, 40 meters from the foot of the tree, and then the angle of elevation, that's key, is going to be 42 degrees. Find the height of the tree. All right, so if we draw and say, okay, on a point on the ground, there's my point on the ground, that's 40 meters from the foot of a tree. So I'm going to make this my 40 meters, and then my tree. You can draw the tree any way you want. It can just be a straight line. Maybe we can go a little, Christmas tree style. There's my tree. I don't know what that is. All right. It's saying the angle to the top is 42 degrees. So angle of elevation, straight out. And then if I'm looking up, that is 42 degrees. Is it perfectly drawn to scale? No. Does it matter? Nope. So find the height of the tree. All right. So this right here, that is going to be the height of my tree. So once I have it set up, I need to then figure out, how do I solve this? So here's 42 degrees, and I've got a side length. This is a perfect setup to be able to use some trig here. So this is my opposite. We're assuming that that tree is perpendicular to the ground. So this is the hypotenuse. Here's the adjacent. So when I have the opposite and the adjacent, that is the TOA of SOHCAHTOA, or tangent. So tangent of 42 degrees is equal to x and then over 40. Well, now we know how to use basic old trig and inverse trig. In this case, because I have the tangent of an angle, I don't need inverse trig. This is where to get x alone, I would just multiply both sides by 40 to get it to cancel here, and that will give me my answer. So 40 times tangent of 42, that's going to give me 36. And it says to the nearest meter. So 36 meters for the height right there. That's it. So you just have to create the diagram first. Now, did I really need to fully draw a tree? No, a stick is perfectly fine there. So with this next one, and it says from the top of a lighthouse 165 feet above sea level, the angle of depression of the boat at sea contains 35 degrees. Find the nearest foot, the distance from the boat to the foot of the lighthouse. All right. So in this case, maybe here's my cute little lighthouse. See, shining light. All right. It is 165 feet above sea level. Oh, okay, lovely. All right. So down here to wherever my sea level is, this is 165 feet. All right. The angle of depression of a boat at sea. So if you're at the top of the lighthouse, if you're looking straight ahead and then looking down, that's an angle of depression. That's 35 degrees. So extend that all the way down until you hit the water. There would be my cute little boat. All right. Find to the nearest foot the distance from the boat to the foot of the lighthouse. So we used our 165. We got our angle of depression of 35. We want the distance from the boat to the foot of the lighthouse. So over here, that's going to be that distance right there. Again, we assume the perpendicular. I promise you, not trying to trick you with that. All right. 35 degrees is not inside my triangle, but we said these are alternate interior angles. So I can draw the 35 degrees right here so that it is inside my triangle. And now that would make the 165 the opposite. That makes the x the adjacent. And so if I have opposite and adjacent, there's that trig or tangent setup, excuse me. Again, so you're going to see a lot of tangent with these questions. Not always, but a lot. So tangent of 35 degrees is equal to 165 and then over x. Again, I have the angle I'm taking the tangent of. So this is just one where I'm going to multiply x on over and then divide to get the x alone. And so then into my calculator, then I get to go, let me darken that up a little bit. 165 divided by the tangent of 35. If for any reason, if your answers aren't matching mine, double check that your mode is in degree mode, right? So 235.6 and change. So to the nearest foot, about 236 feet. That would be how far away the boat is from the base of the lighthouse there. All right, moving on. Find to the nearest degree the measure of the angle of elevation of the sun when a vertical pole 6 meters high casts a shadow that's 8 meters long. All right, this one for some reason sometimes messes with people. So what I want you to think of, here's, the ground, and you just have this vertical pole. So that's easy enough to draw. All right. The vertical pole that's 6 meters high. So this is 6 meters. It casts a shadow that's 8 meters long. Think about where your shadow is. It's on the ground. So down here, I can make this my shadow is 8 meters long. So when it's asking you for the angle of elevation of the sun, if the shadow is over here in my picture, the sun is, over here somewhere. And so it's casting that shadow onto the ground. So that's what closes up the triangle. Now, when it says, what's the angle of elevation? All right, well, that means if we're looking out and looking up, that has to be this angle right here. That's going to be my angle of elevation. And so we can put X right there. That means opposite, adjacent. That would be my hypotenuse. Remember I said we were going to use a lot of tangent? Set it up. So tangent of X this time equals 6 over 8. All right, now since we don't have what we're taking the tangent of, we have to get rid of the tangent by using inverse tangent. So if we take the inverse tangent of both sides, grab your calculator, that's going to be second tangent, 6 over 8. And we get 36.86 and so on. So it says to the nearest degree. So that would be roughly 37 degrees for my angle of elevation there. So we've seen a little bit of each. We saw one where x was in the numerator, x was in the denominator, oops, right there. And then we saw one where x is the angle measure itself. So it can move all over the place. So on this next page, let's do one last one together. Let's see, if we do number 5, we've got a ladder's leaning against a wall. The foot of the ladder is 6.5 feet from the wall. The ladder makes an angle of 74 degrees with level ground. All right, how high on the wall does the ladder reach? Round your answer to the nearest tenth. So you have a ladder leaning against the wall. So if here's my wall over here, and obviously this would be my floor. Right? The ladder leaning against the wall, something like this. So here's my ladder. The foot of the ladder is 6.5 feet from the wall. So here's the foot of the ladder, or the base of it, 6.5 feet from the wall. So that's 6.5 feet. And it makes an angle of 74 degrees with the level ground. All right, so the ladder and the ground, that angle, 74 degrees, which makes sense. If you've ever leaned a ladder against the wall, you don't want it to be super far away. It would be pretty close, and therefore it'd be a pretty steep angle. All right, how high on the wall does the ladder reach? So that's this distance from here to here that we're looking for. So from here down to there. All right, here's my angle. There's going to be my opposite, my adjacent, my hypotenuse. Should be no shock that this one came out tangent as well. So tangent of 74 and then equals x over 6.5. I want you to finish out that question and answer it in the video. The other two we will save for a little recap for class. Thanks so much for watching, guys.